It is 2 hours UTC, and it's time again for Astronomy Daily Live. So, hey, everybody, come on in, join the ever growing circle of friends who come together practically every single day. Every single day. Doesn't matter what day of the week it is, doesn't matter what day of the month it is, doesn't matter holiday, whatever. This is going to happen. Now, from time to time, uh, there will be an occasion where the live stream will be canceled, and I will let you know in as far advance as I can possibly do that. So, Bobby, hey, what's going on? So I'm going to turn you down and turn me up. And anybody in the chat, let me know if that's not acceptable. Doesn't have to necessarily be perfect, but if it's acceptable, good. So yeah, I hope everybody's doing well out there. Everything's good here. I just had a just sort of a regular day, just sort of working on a couple of things. One of the things that I was a little bit excited about a few days ago was the possibility of using stellar occultations to detect trans-Neptunian objects. And well, I've been going through the math, and everything looks good except the last thing that's the most important thing. And the most important thing is the probability that I will actually be in a location where I can see the occultation occur. And it turns out that that probability is still really, really, really low. Now, I need to look at a little bit more data, because what I'm doing is I am getting the ephemeris of a trans-Neptunian object or objects. And an ephemeris is just the positions of a target over time. But it can give you other information like, distance and brightness and how fast it's moving, all that stuff, right? But it can also tell you where in the sky it is, right? So if you can know that, then you can look and see from your location. And I'm going to go to first person here. My location. If I can see it from my location, I would think that an asteroid would, pass in front of a star that I could actually see, right? But it turns out that the probability of that happening exactly at my location, even plus or minus 100 kilometers, even that is a very, very, very small chance. Now, I need to look at a little bit more data, because, as I said, what I can do is I can look at the position of this object as it moves against the background stars, and I can see if it passes in front of any of those stars. And I can get a star list, a very, very good star list, from Gaia, right? I can say, give me the position of every single star in a certain area of the sky, down to a certain brightness, down to a certain magnitude. Hey there, Uncle Bill. See you in the chat, painting the chat yellow.
Hey, Uncle Bill.
Yay. So, but yeah, it turns out that because these TNOs are so far, are so incredibly far, they have to, you know, even though they're relatively large, their shadows cast on the Earth are, on the order of 100 or 200 kilometers wide. So that's a very, very wide shadow. But the problem is that they are so far away that um, that shadow, if the asteroid passes 1 arc second away from a star, that translates to something like 2,000 kilometers off on the Earth, and so that shadow could actually appear anywhere within that 2,000 kilometer range, but it's only 100 meters in diameter, say. So the chances of it actually going over me is 100 divided by 2 million. So it's a very, very, very small chance, and that kills it. That just that kills the project. So I hate that. I hate that. Come up with sort of an interesting idea, and it just it looks really, really, really good, and then, at least in my case, right? I mean, the last thing I looked at, I mean, I've spent almost a good year on this, right? Trying to figure it all out, and the last thing I look at, it couldn't have been the first thing I looked at, right? The last thing I looked at was the thing that kills it. It's like, yeah. So
I mean, you tried something and then you nuked it.
yeah, no, it nuked itself. It was just it's not a doable thing. Not I mean, well, it's doable, but it's extremely expensive. So yeah, no way. I mean, what you would have to do is you would have to have um, this long array of telescopes spaced 100 meters apart, extending 2,000 kilometers. That's what you would need in order to do what I thought would be extremely easy. So I mean, it's doable. It's just it's not gonna happen, right? So cheers. This is definitely hydrogen hydroxide tonight. HOH. So right. Freshly brewed this morning. Yeah. Got to make a new batch pretty often out here. So Astronomy Daily Live. Let's see. I can't think of any other updates. There's always exciting things going on in the background, but not anything to get too excited about. So yeah, always seem to have things on the burner. that look really, really interesting, and it's like, I wonder how those things are going to cook. I don't know. Now, I was pretty prepared last night or yesterday to do some imaging of some HST data, and I think we should still do that. But I also thought that we haven't. I don't think that we've looked at Mars recently, at least. And so I went over and looked and saw if HiRise had any new pictures, and they do. So I'm going to start up my smartphone here, just like that. Come on. And let's just spend a little bit of time just looking at Mars. Not a lot of time, because as I said, I think I want to make some pictures. So let's see. Layered material in Melis Chasma. I always thought, this platform has been above Mars for like 10 years now, right? I think over 10. And I always thought that I would like to know a person who, writes these things, because sometimes there are. What's that, Bobby? Sorry.
I'd like to say hello to Andy Cogley.
Andy, hey, how's everything? Nice to see you in the chat. We're looking at Mars. I just had I don't think that we've been over here recently, so it's like, yeah, let's do it. So not much of a description here. Sometimes there are like really, really long descriptions, and let's see if and I'd like to know who writes these, because it's got to be a fun job, right? To sort of describe this stuff. So, but at least in this case, it doesn't look like there's a description. So what I like to do is I just like to look at the regular grayscale. Just this is sort of the most raw image, right? It seems to be sort of the highest resolution one too. Usually get a strip that we can zoom in on. Ooh. So hold on. I always like to look and see what the pixel resolution is. So 57.9 centimeters per pixel. So a couple of feet per pixel, right? For us Anglos. All right, now let's look at it. So, yeah, half a meter per pixel. So that really helps me get a sense of scale, right? Because I mean, we really can't see pixels here, right? I mean, if I were to save this and put it into something else, we could zoom in a lot more. But at least at the full resolution of this laptop, we're not seeing pixels. So we're seeing something much bigger than that. So probably what we're seeing now, maybe a resolution of, I don't know, 5 meters, maybe an order of magnitude more. I don't know. Maybe not that many, but 1 or 2 meters is probably a pixel size. So you can sort of, based on that, right? I want to say that sort of the distance between these ripples here, I don't know, is probably 10 meters, something like that. So, you could definitely walk in between them. And wouldn't that be a trip? Buffering. Anybody else seeing buffering? All right, let's move down. Let's see what's wow. Look at those layers. Pretty amazing, huh? And I guess this is a crater.
For quite some time, huh?
Well, Bobby, that's the going story, but I don't know. I mean, it sounds like a reasonable story, but yeah, I don't know. Sounds a little, I don't know, a little boring. I think the universe is much more active than what we think. I think, as I was saying yesterday, right? I think that we're lucky to be existing in this extremely benign environment, right? I mean, pretty constant temperature. No, I mean, the most active solar flares on the sun that we've seen, at least aren't going to burn the planet to a crisp. So pretty amazing though. Wow, look at that. That's kind of an interesting shape there, huh? Look at that. That's like a pentagon, isn't it? 3, 4, 5. You see that? 1, 2, 3, 4, 5. Huh. Kind of interesting. Pretty cool ridge. Look at this weird stuff down here. So here's some different kind of material. Brighter, I guess you'd say. Don't know what that is. Don't know if that's if that's like CO2 ice, or I don't think it's clouds, but it might just be a different kind of dirt. Hard to tell. Cool looking though. More, I guess you call these dunes. What do you think of this, Bobby?
Kind of like crazy and stuff.
It's insane. I always like to imagine though, walking around down there and looking up at these things.
Yeah.
What an amazing view that would be. Walking around in these side areas, looking down into a crater, must be pretty amazing. That's a pretty crazy looking place.
Yes, and like one of these days we will be like walking in Mars.
We sure will. Something I always say, right? I quote Carl Sagan all the time. It's like, if we don't destroy ourselves, we're in for some awesomeness, and I mean soon, right? I mean I can't even imagine 100 years, right? I can't possibly imagine. If it's anything like the past 100 years, holy moly, who knows, right? But yeah, maybe not necessarily us, you and I, but somebody may be alive today. If things go according to plan, somebody alive on the planet today will be walking on Mars. And I think that's a pretty cool thing.
Now, have you seen the movie Interstellar?
I have not. I try to stay away from sort of movies that I sort of know too much about in terms of the content, because they tend to just drive me crazy.
Um, what about The Martian?
The Witch?
No, The Martian.
No, haven't seen that one either. I'm kind of a rotten egg on that one too. It's it's I got through about half of the book, and got like really bored, because it's years and years ago I read Robinson Crusoe, and that's all that is. I think it's more or less the same story. So yeah, I guess I'm sort of a downer on that one. But I tried to read the book. I definitely really tried. I just couldn't. And there aren't too many sci-fi books that I won't finish. But that was one of them. So yeah, I'm sort of a downer on that. Didn't see the movie.
Yeah,
It was
be right back.
yeah. The Martian, I think won awards. Um, okay, Uncle Bill, sorry about that. I don't think that we've had any slow internet today. I mean, these pages, these images that I'm loading here are coming in pretty good. Wow, what is that? Oh, wow. Look at that. Just dunes. Just this huge dune field. Look at all these. That's pretty interesting. I'd like to increase the contrast of that. So I am
Yeah.
going to save this image, and we're going to open it up in GIMP, because I want to increase the contrast here a little bit. You know what I mean? So I'm going to save that. And we're going to go over here. And I guess I'm going to have to... Yeah? Yeah? Am I back? Yay. All right. All right. Sorry about that. I X'd out my Google Hangouts, and but I I just restarted it through YouTube, and yay. So um, Bob, if you're watching, try to get back on. If it doesn't look like if it doesn't look like you can use that link, I'll send you the new one, because maybe there's a new one. All right. Sorry about that. It happens. It happens. So what we were doing was we were going to save that image, and I wanted to work on the contrast a little bit. So here we are, and I'm going to open it with GIMP. Open with, ooh, it's not one of the, come on, GIMP. GIMP. There we go. Yeah, that's so funny. Technology is just, you know, it's like a thin little thread, and you know, if you pull too hard, it's like, oh, it breaks.
A great tornado just happened.
What's that?
What a great tornado just happened.
I X'd out my Google Hangout window, and so everything went away for a little bit, but some reason a miracle occurred, and I was able to just restart it all, and here we are. All right, so GIMP is up. Oh, it's still loading. I really like this picture. Here, we'll do the infinity thing while it loads. Is this slowing it down? I don't know. Probably not. There we go. Just going back to infinity. It's great. So, you know, when you look at it at this magnification, right, it looks like funny looking clouds or something, right? But then we go to 100%. Let's go to 200%. There we go. There we go. It looks like a fingerprint. What do you think of this, Bobby?
Kind of interesting to colorize it.
Yeah, to colorize it, what I'm going to do is I'm going to change the brightness and the contrast. So maybe so that's pretty amazing, though. Let's see. Let's whoop! It's doing it over the whole image. There we go. Let's shrink it down. Yeah, I really can't. Wow, look at that weird looking thing there. Huh. I didn't notice that before. You see that? Wow, that's really weird looking. Isn't that really weird looking? Or am I just seeing things weird?
It's good. Wear it all.
That is really weird looking. I can't really. Let's zoom in a little bit more. Wow, that's pretty weird looking. Huh. I mean, these look like boulders,
Yeah. Yeah.
like bright boulders.
You'll bite. Bubba won't give you a
Yeah,
bite.
this has got me. This has got me hurting in the brain for sure. Pretty interesting, no? Gotta say. Let's see. Let's look at 100%. Let's.
Sorry about that. My uncle just made the room.
Hey there, Uncle. Pretty overexposed, pretty bright down there. Kind of interesting that it does that. Pretty bright down there too. Wow, what a bizarre landscape. Huh. That's what the original looks like. I want to look at that thing in the middle again. If we can find it this way. Well, must have missed it. Oh, there it is. Oh, it's really faint. Yeah. Pretty cool. All right, what else do we have here? Come on, you. So that's the Argyre region. Okay. Okie dokie. Fans in region of non-cryptic terrain dubbed Buenos Aires. Okay. See what the resolution here is. So it's about 0.5 meter a pixel. Oh, that wasn't it. So 0.5 meter a pixel. This has been doing this. It doesn't roll it. It just blasts on there. Boom. That's pretty bizarre looking too. Just an amazing place, you know. I mean, these little dots here, right, are, well, at least a few pixels across. So, you know, you're looking at maybe 2 or 3 meters across here, these little ones, whatever they are. Huh. Pretty weird. Can't quite decide what those things are. Not quite sure what we're seeing. Oh, it's just a little bit of bumpiness there. See that? A lot of that, depends on the solar angle, right? So the sun is probably practically right behind them, I would think, because yeah, this is casting almost no shadows at all. I would think that if the sun were at an angle, these little bumps would cast some shadows, but it's pretty bright. I can't figure out if these things are going up or if they're going down or none of the above. I don't know. I don't know what these are. Look at this bumpy terrain. Look at that. Huh. And it's almost a really sharp line, right? Right there. Huh. Cool. Here's like a patch. See that? Huh. That is completely beyond my comprehension. Does it say anything about it? Oh, yeah, just the non-cryptic terrain. I don't know what non-cryptic terrain is either. That's kind of a weird term. Huh. I think that if there was a way to get back, I would probably go to Mars. Now, for sure, what I would love to do is a 5 or 6 day cruise. You could call it the Apollo 8 cruise, right? You go out to the moon, you go around it, and then you come back. And, you spend half a day or a day in orbit around the Earth on the way up and on the way down. So you get to look at the Earth, and then you get to go around the moon, and then you get to look at the Earth again, and then you come down. I think that would be great. I would be extremely interested in that. Mars is sort of a different thing, right? Because it's so much further away that, you really don't have a good option for, like, if you're going to go, you need to make like a 2-year commitment just to go and come back. So that's pretty long. I mean, you can get there faster, but I think getting there faster would be much more expensive. So craters. And sand dunes in the craters. Pretty cool looking. Look at these odd-shaped ones. It's probably caused, but I mean, if you go with the story, this is some kind of an impact, then it's probably a bunch of them, that sort of impacted almost at the same time, almost in the same place. So they make these little shapes. That's one story. looks like the sun is what, maybe almost due. Well, no, I guess the sun is over here, right? So the sun looks like it's coming from the west, probably relatively low. Let's see. I think they tell us what the solar angle is. Let's find out. Not too far. Let's see what the solar angle is here. I think they give us solar angle. So the sun is 37 degrees above the horizon. So, you know, that's pretty low. That's what, like, I don't know, 4 in the afternoon. Or what, 8 o'clock in the morning? Whichever you prefer. Oh, over here. Okay, we did that part. Right, just moving up. Moving up. A box of 4 of them. Look at that. Doing. I guess there's another one over here. Huh. Makes a W. Very cool. Kind of weird looking things around these craters. Huh. Odd shape too. Mars. Just amazing. Okay, let's look at one more and then let's do an HST Messier object. So let's see. Crater wall. Let's move on to the next one. How do we do that? Oh, right here. Central peaks of impact crater. So these were all, as you can see by the date there, these were all uploaded on the 11th of July, so a few days ago. I want to show you all those so-called dust devil paths, but I haven't seen any pictures of those lately. I used to see a lot of them. Let's see what this looks like. Wow. So 0.5 meter a pixel again. So 4 degrees above the horizon. So this is at sunset. That might look interesting. It already does. Cheers. Okay, nothing too interesting at that resolution, but wow. So Bobby, do these look like they are coming out at us, or are they going in the cracked part? You know, the wiggly part. Is that going in, or is it coming out?
looks like they're like coming out and stuff.
Yeah, I think that these are going in. I think they are, although they really look like they're coming out. But you know, it could be either way. But look how, I mean, these are really like they're all sort of polygons, right? Sort of polygons. They've got, some of them don't have exactly straight lines, but
So
a lot of them do, and they're all about the same size.
I wonder if the black spots are called a fan.
Yeah, I guess so, but I don't know, what are those? I don't know. I mean, they're extremely cool looking. I mean, look at that. But I have absolutely no idea what I mean, is it a, I mean, it looks like a different kind of material, right? Like really dark. That's just sort of been spewed or sprayed, or I don't know.
Now, I'm wondering if you ever heard from Our Water lately.
She posted a thing over on the Discord server that she was going to be out for several days. She was going to be on the road, and yeah, I think um, Uncle Bill responded because she's working with some kind of a like a production company, or I forget exactly how she put it. Some kind of I don't know, some kind of play or something, and so yeah, I want to know a little bit more about that. You know, whether she's acting, or if she's, you know, what's her involvement in that, because that sort of sounds a little bit cool. But yeah, she's going to be out, I think, for the next few days on the road.
Interesting.
So it's pretty interesting how all these are sort of the same size, and then there's a lot of them, right, that are square, and then have the, you know, kind of cool. But yeah, you know, it really looks like they're popping out, but I think that's an optical illusion. I think they're going in.
Sand dunes on Mars tend to be very dark, but they have a sort of crescent shape usually, says Uncle Bill Doran.
Yeah, I don't think these are sand dunes. I know what Uncle Bill is talking about. We've looked at those, and no, these aren't dunes. These are definitely. I mean, well, look. I mean, I can't know, but these definitely do not look like dunes. Pretty cool though, for sure. Seasonal fans. Huh. I don't know. You got me. Seasonal fans. All right. Well, let's go over to random.org, and we will choose a Messier object, and then we'll go over to the HST archive and see if we can make a pretty picture. There's 110 Messier objects. And random.org will choose the Messier object that we are going to try to find. So here we go. M8. M8. Ah. Okay. It's gonna kill me. Know which one? You know which one that'd be? Messier 8. Oh, it's gonna kill me. Oh. This is the Lagoon Nebula. Oh, I didn't have to do that. What am I doing? Silly boy. Oh, M8. Oh. I would get a nebula. Oh, we're not going over here. Sorry. Where my brain is. Lost. Here we go. M8, HST. Oh, let's just look at images. There's going to be a lot. Oh, there's not as many as I thought there would be. Thought that there'd be a lot more than that. So 1993 with WIFPIC. That's 1995 with WIFPIC 2. Let's see. 200-second exposure. 65, 64 angstroms. Central wavelength. M8, it says. Ooh. Oh, okay. Oh, that could be interesting, you know? So let's do it. Let's call it M8001. Okay, so that was that one. Okay, so now we can do a different wavelength. We've got 502 and 547. They're sort of close to one another. Let's choose 547 because then that's the furthest one away from 487. So we can go red, green, and blue. So let's go 547. And hopefully it's the same location. It is. Okay, so let's save that as number 2. Oh. Gotta go back. This is number 2. That's going to be the green one. And then 487. This one. Pretty long exposure. Ooh. I'm kind of anxious to see what this is going to look like. Because I really don't know. But let's look. All we can do. So 1 is going to be red, 2 is going to be green, and 3 is going to be blue. So it sort of follows the wavelength. This must be, I want to say this is like just a portion of the nebula itself. Here, let me show you a full picture. You know what? We can do this. Lagoon Nebula. Come on, you poor machine. So they call this an emission nebula because, for the most part, this gas is glowing. It's emitting light, as opposed to reflecting light, which it actually also is doing. But whoop. Come on. It's going. Wow, that's loading. Can I do that? I'm really pushing this poor laptop to its Okay, come on, you got to give. Hmm. Okay, so we can get started with this, maybe. I pushed the button. It's being really slow. Looks like I've still got a live stream going. Yeah, still got a live stream going. It's just being really slow. And this picture is not coming up, so let's just do that. Because I want to get on with this. Here we go. Open his layers. And let's see, we got to go through the whole path here. Sorry. Downloads. Whoop. Astro. Okay, I'm going to put you down just for a sec. Making me do it one at a time. Okay, so once this is loaded, we will turn this into an RGB. Okay. And then we're going to come over here and we're going to say screen. And this one's going to go to screen. So this is just adding them all up. That's basically what it seems as though that mode does. So now we know that one we want to be red. Now we can choose any color we want, right? At this point, we can choose any color we want. I mean, on modern machines. Say that again, Bobby. Sorry.
Are those engines supposed to be inverted, or they're okay like that?
I think they're okay like that. We're going to find out. I'm going to colorize. I'm going to make this red. Where was red? Oh, there it is. Okay, so that one's red. And this one's going to be green. And I think green was down about there, right? It's a nice green. It's going to be a little bright. So number 3 is going to be blue, but we can work on the brightness separately. So blue, whoop, something like that. Okay, so it is definitely really bright. So, let's try this on each of them. Just do an auto white balance. I don't think that's going to help. That did not help in any way whatsoever. Okay, undo colorize. No, I don't want to do that. Let's just see if I can. I'm not sure if the data has been saturated or if it's still actually there. If it's still actually there, then we should be able to change the brightness and contrast. Now I think it's washed out. Yeah, it's washed out.
That should look like a little bit better.
Merge. Okay, so there I've got my 3 back. Is there an? I thought there was an add. There it is. We'll play around a little bit here. See if we can get somewhere. No, that's not really doing anything. Sometimes division is kind of interesting. Sometimes. Doesn't look like it's going to be this time. Nope. We can look at difference. Ooh, there we go. So let's change one of these to screen. Okay, well, that's not exactly what I was looking for. How'd we have that before? We had this divide and this difference. Yeah, that actually makes for the most interesting one. That's kind of cool. Let's try to colorize those in the same way. Because now we've got some a little bit of balance. But you know, sort of the reason why I do this is to show you that the choice of color is almost arbitrary, and the choice of processing is almost an arbitrary thing. It's sort of like, what are you trying to see? So there's the red. Whoop.
And say hello to Cat Brownie.
Say again, Bobby?
I'd like to say hello to Danielle Brownie.
Oh, Daniel, you're back. Hey. Hope everything is well over there. We're looking at M8, the Lagoon Nebula. And I've been trying to make a moderately pretty picture from HST data, but yeah, that's looking a little funky. So I don't know. But that's false color, right? And it's all sort of false color. We can try, to mimic what we see, but it's kind of hard. But that's not bad. That's difference. Yeah, I sure wish. Let's see, can this come back on? This is divide. Let's see if difference. That's kind of interesting looking. That's kind of cool, eh? Look at this line right there. Look at that. Goes all the way around over here. Huh. Whoop. Oh, I don't know what I'm doing there. Oh, I see what I'm doing. Changing that up there. Difference. There we go. Oh, that's pretty cool. That's kind of interesting. It almost, you know what? It almost looks like these aren't lined up. You see? I'm sort of wondering if I need to move this red around. Let's see. Oh, okay. Well, that's not the red one, obviously. Layer. Okay. Which one is the red one? I don't know. I wonder if it's that one. It's going to be hard to see. Let's find out. There we go. I don't know if I line up. Yeah, that's definitely not right. I guess that's right. Okay.
Looks okay to me.
Yeah, I guess so. I guess I was just sort of, I'm looking down here, right? I'm looking down here, and I'm seeing this edge and this edge. And my brain says it's like, those should line up, but no, I guess not. Because then nothing else does. That's kind of cool. I'm going to save that. I'm going to save the GIMP file, and I'll save it as a JPEG. Or as a PNG. Yeah, I'll save it as a PNG. And then I'm going to stick it over on the Discord. Let's see. Discord. All right. Well, as I'm doing that, wind this up for today. It's always great to see some nice HST images, and a little bit of luck. We got a kind of an interesting looking image of M8, the Lagoon Nebula. So there are stars inside of this nebula that are primarily why that whole area is lit up, due to ionization from the stars themselves. That's then making this gas and dust glow, but it's also reflection. So we'll go over here. Oh, where is it? Oh, I don't see it there. Oh, because it wants me to do that. I think it's doing it. Yeah, it's doing it. Let's see. Is it done? Yeah, it's done. There it is. M8. Lagoon Nebula. HST. Prop ID. Get the proposal ID. Uh-oh. You have to find it again. Luckily, it's a short name. It was proposal 6227. 6227. Always want to give credit, right? That's why I do that, because this is not mine, right? It sort of is. It's sort of all of ours. So there we go. I think with that, I'm going to get out of here, depart these waters. I'm just gonna stop sharing. That's all. All right. Well, cool. So, well, thanks for coming in, you all, again. Greatly appreciate it. Daniel, nice to see you in the chat again. That is really great. Hope you're having a good day over there, and yeah, have a great afternoon. And where I am, I'm going to have a great evening. I've got another few minutes, and I'm going to crash and burn, as they say. So, all right, out of here for now. So take care, everybody. If you haven't subscribed yet, make sure to do that, and share this around. We're looking for our core group. All right, I'm not trying to cast any kind of wide net or anything. I'm trying to harpoon So spread the word around. This is just a lot of fun, and we talk astronomy and look at cool things and think about cool things for an hour-ish or so every single day, 2 hours UTC. All right, I'm gonna get out of here for now. Take care, everybody. I will see you on the spin. Bobby, peace and cheers, man.
All right. See you later.
See you on the spin. Bye.